Today we're starting our Chapter 1 notes, looking at Section 1-4, solving absolute value equations and inequalities. Today we're actually going to be solving absolute value equations. Recall that absolute value is the distance from 0 on a number line. The notation for absolute value is 2 vertical bars. The absolute value of -7 is 7, because if we were to look at the integer -7 on a number line, it is 7 units from 0. The absolute value of 7 is also 7. So if the absolute value of x is equal to 7, then x is equal to -7, or it could be equal to +7. In general, an absolute value equation, such as absolute value of ax plus b equal to c, c being greater than 0, is equivalent to the following two equations. Ax plus b is equal to -c, or ax plus b is equal to c. Steps for solving absolute value equations. First thing, you isolate the absolute value portion of the equation. Drop the absolute value symbols and write two separate equations, one equal to -c and the other equal to c. Solve each individually and check both answers back into the original equation. The best way to see this would be with an example. Again, you must check your answers back into the original equation once you find your two values. We want to solve the absolute value of 3x minus 7 equals 10. Well, the absolute value is here on the left-hand side all by itself. So we start off by splitting it up into two separate equations. 3x minus 7 is equal to -10, or 3x minus 7 is equal to 10. And now we solve them individually. Add 7 to both sides here. 3x is equal to -3. Divide both sides by 3. X equals -1. Add 7 to both sides of the equation here. 3x is equal to 17. Divide both sides by 3. And x is equal to 17/3. And we're fine with leaving the fraction 17/3. Now we must check back into the original. So we're going back to our original absolute value equation and checking our two values for x. So the absolute value of 3 times, I'll replace x with -1 first. Subtract 7. Does that equal 10? 3 times -1 is -3. -3 minus 7 is -10. And the absolute value of -10 is 10. So 10 equals 10. That checks. Now checking 17/3. The absolute value of 3 times 17/3 minus 7, does that equal 10? 3 times 17/3 is actually 17. Minus 7 is 10, and the absolute value of 10 is 10. So both values for x check. So our solution is, and we're using solution set notation, -1 and 17/3. Page 2 of our notes. We have 3 examples we want to work through. Solve each of these equations for x, use solution set notation for your answers, and check your answers back into the original equation. Absolute value of 5x minus 10, subtract 4 equals 11. We need to isolate this absolute value. So the first step is to add 4 to both sides. So the absolute value of 5x minus 10 is equal to 15. Now that the absolute value is isolated, it's all by itself, so now we split it into two separate equations. 5x minus 10 equals -15, or 5x minus 10 equals 15. And solve individually. Add 10 to both sides. 5x is equal to negative 5. Divide both sides by 5. X equals negative 1. Here, adding 10 to both sides. 5x equals 25. Divide both sides by 5. X equals 5. Now check. Going back to the original absolute value equation. The absolute value of 5, replacing x with negative 1 first, times negative 1 minus 10, subtract 4, does that equal 11? 5 times negative 1 is negative 5, minus 10 is negative 15. The absolute value of negative 15 is 15, minus 4 is 11. When you're checking, you work out the left-hand side of your equation and the right-hand side of the equation. Checking the value of 5, the absolute value of 5 times 5 minus 10, subtract 4, does that equal 11? That's 25, subtract 10 is 15, and the absolute value of 15 is 15, and 15 subtract 4 is 11. So both values for x check. So our solution is negative 1 and positive 5. Our next example, we have the absolute value of 1/2 x minus 10 equals 30. The absolute value is already by itself, so we start off by splitting into two separate equations, dropping the absolute value bars, setting it equal to negative 30, and also equal to 30. Solving individually, adding 10 to both sides, 1/2 x is equal to negative 20. Now, you can divide by a half. Dividing by a half is the same as multiplying both sides by the reciprocal of 1/2, which is 2. So multiplying both sides by 2, and I get x equals negative 40. Add 10 both sides, 1/2 x is equal to 40. Again, multiplying both sides by the reciprocal of 1/2, x equals 80. Now for the checks, go back to the original absolute value equation. Plugging in negative 40 for x. Half of negative 40 is negative 20. Minus 10 is negative 30. And the absolute value of negative 30 is 30. So that checks. The absolute value of 1/2 times 80 minus 10. 1/2 of 80 is 40. 40 minus 10 is 30. And the absolute value of 30 is 30. So both check. So we have as a solution set negative 40 and also 80. And our third example, the absolute value of x subtract 4 equals 3x. We need to get the absolute value of x by itself, so the first step we do is add 4 to both sides. And now we have the absolute value of x is equal to 3x plus 4. Now split it into two separate equations. So we drop the absolute value bars and say x is equal to negative, I'm going to put parentheses, 3x plus 4, because that's a binomial. That's two terms that are on the right-hand side there. Or x equals 3x plus 4. Distribute the negative over the parentheses. X equals negative 3x minus 4. continue solving. I'll add 3x to both sides and get 4x is equal to negative 4. Divide both sides by 4, and x equals negative 1. Subtract 3x from both sides on our other equation. Negative 2x is equal to 4. Divide by negative 2. X is equal to negative 2. Now we must check our two solutions back into their original absolute value equation. So first taking negative 1 and checking, is the absolute value of negative 1 subtract 4 equal to 3 times negative 1? The absolute value of negative 1 is 1. 1 subtract 4 is negative 3. 3 times negative 3 is negative 3. So the x value of negative 1 checks. The absolute value of negative 2 subtract 4, does that equal 3 times negative 2? The absolute value of negative 2 is 2, subtract 4 is negative 2, 3 times negative 2 is negative 6. They're not equal. So our x value of negative 2 does not check. So negative 2 is not a solution. So our only solution here is negative 1. Now on page 3 of the notes, so try the next 3 problems on page 3 on your own. Remember to isolate the absolute value and then split into your two equations, solve, and check your answers back into the original. So pause the video. Okay, so number 1, we have 2 times the absolute value of 5x minus 5 is equal to 10. So we need to isolate the absolute value of 5x minus 5. So we undo the multiplication by 2 by dividing each side by 2. So we have the absolute value of 5x minus 5 is equal to 5. Now that the absolute value is isolated, we split into two equations, dropping the absolute value symbols, setting it equal to negative 5, and dropping the absolute value symbols and setting it equal to 5. Now solving individually, adding 5 to both sides here, I get 5x equals 0, dividing by 5, x equals 0. Adding 5 to both sides, 5x equals 10, dividing both sides by 5, x equals 2. So we have these two values for x, but now we must go and check them. Does 2 times the absolute value of 5 times 0 minus 5 equal 10? 2 times 5 times 0 is 0, minus 5 is negative 5, and the absolute value of negative 5 is 5. And 2 times 5 is equal to 10. So 10 equals 10. So the x value of 0 checks. The x value of 2 is 2 times the absolute value of 5 times 2 minus 5 equal 10. 2 times the absolute value of 10 subtract 5 is 5, and the absolute value of 5 is 5, and 2 times 5 is 10. So both 0 and 2 are solutions. Number 2, isolate the absolute value of 3x. So subtract 4 from both sides first. The absolute value of 3x is equal to x minus 4. Now split into two separate equations. 3x is equal to negative x minus 4, or 3x is equal to x minus 4. Distributing the negative, negative x plus 4, adding x to both sides, 4x is equal to 4, and divide by 4. and x equals 1. Subtracting x, 2x is equal to negative 4, dividing by 2, x equals negative 2. Now for the checks. Does the absolute value of 3 times 1 plus 4 equal 1? 3 times 1 is 3. The absolute value of 3 is 3. 3 plus 4 is 7. 7 does not equal 1. So 1 does not work. 1 is not a solution here. Does the absolute value of 3 times negative 2 plus 4 equal negative 2? It's negative 6. The absolute value of negative 6 is 6, plus 4 is 10. Well, 10 does not equal negative 2. So negative 2 does not work. So there's no solution here. So our solution set is what's called the empty set. So it's just our set notation with nothing inside of it. And our last one, the absolute value of 2x plus 7 plus 20 equals 15. We'll subtract 20 from both sides to isolate the absolute value portion of our equation, and we get negative 5 on the right side. Now think of that for a minute. Let's continue on. 2x plus 7 equals negative negative 5, or 2x plus 7 equals negative 5. 2x plus 7 equals 5. Subtract 7 from both sides. 2x equals negative 2. Divide both sides by 2. X equals negative 1. Subtract 7 from both sides here. 2x equals negative 12. Divide by 2. X equals negative 6. Now we must check these two values for x. The absolute value of 2 times negative 1 plus 7 plus 20, does that equal 15? Negative 2 plus 7, that's 5. And the absolute value of 5 is 5. So 5 plus 20 is 25, which does not equal 15. So 1 doesn't work. Sorry, negative 1 does not check. The absolute value of 2 times negative 6 plus 7 plus 20, does that equal 15? It's negative 12 plus 7, which is negative 5. The absolute value of negative 5 is 5, plus 20 is 25 again, which again does not equal 15. So there is no solution. If we go back to number 3 here and look at number 3, what is different about number 3? Our absolute value here of 2x plus 7 was equal to negative 5. So the absolute value was equal to negative 5. What can't an absolute value equation be equal to? A negative number. Why not? Because distance from 0 on a number line is not negative. This is a vocabulary term, extraneous solution. Extraneous solution is a root. Now, a solution and root are the same thing. that is introduced into an equation in the process of solving another equation, but is not a solution of the original equation. And that's what we had here in number 3 and also number 2. Right? If I go back to number 2, we had our original absolute value equation. Once we isolated the absolute value, so we transformed the equation somewhat, and we came up with solutions of 1 and -2. When we went and attempted to check those two values back into the original equation, they did not work. They did not check. So each there is called an extraneous solution. And that concludes our notes for today.